Hello, everyone, and welcome to the GTC conference. My name is Sven Freudenfeld. I'm the CTO of the Telecom Applications Business Unit at Lanner Electronics. And today we will highlight a few of the use cases where we working with partners in the ecosystem to provide solutions for the intelligent edge. We have been investing for several years in defining the edge, including Whitebox Solutions, which containing multiple applications, in particular for the intelligent edge, but also intelligent IoT and intelligent 5G. Most of the applications leading towards a AI infrastructure as a key to optimize the workloads in combination of analytics, but also in terms of predictions of a network. We see AI will take place in multiple areas, not only on the enterprise, but in particular on the intelligent edge and the intelligent IoT infrastructure. What we see for the last couple of years is disaggregating is becoming the trend. Removing the lock-in mechanism of hardware and software combined will give the capabilities of using multiple resources at the edge. That means that not every function will be able to support and sustain general compute. It needs acceleration, but also specific workloads at the edge. And therefore, we have been working closely with our ecosystem partners to provide solutions which can focus on an intelligence at the edge site. We have seen from researchers that most of these network functions moving to either the far edge or the close edge. And some of these network functions require intelligence, which means that analytics as well, artificial intelligence is a key to be more optimized on that. If you look at some of the workloads, for example, virtual CDN, content delivery networks, but also for virtual CPEs or universal CPEs will open the doors for intelligence to be deployed in the network to be more efficient with that. We have created an ecosystem in the area. We're working with close partners. As software partners, as I said, we see the trend of disaggregation. And for the specific GPU workloads, we happy to announce that we are working closely with Tensor Networks. Tensor Networks is focusing on AI at the edge, and it's bringing a solution play for this type of applications. So with that, I would like to introduce Bill Walker. He's a CTO at Tensor Networks. Bill, give us a bit of a background on about Tensor Networks.
Sure, thanks for having me, Sven. So a few years ago, we started looking at the access edge, and GPUs are great for compression and acceleration and encryption and helping that edge node, that point between the premise and the cloud, the point between the users and the data center, actually accelerate and run better. And we started to look at the actual data that was coming through. So we looked at the value of data in each of these places, and where the data is generated, where the data is collected, where the data is sent to the data center or the cloud. And we actually built an operating system called Matrix OS, which integrates the accelerators, integrates GPUs, to do both better networking, faster networking, as well as enable some situational awareness at each of those layers.
Okay, so I think we will look at two specific use cases at the intelligent edge. One of them is using an edge compute appliance in combination with the A10 from NVIDIA operating using the Matrix OS. So Bill, what is Matrix OS in detail?
Matrix OS is a Linux with optimized networking, zero-touch provisioning. So those edges become managed. We always say, manage it as cattle, not as pets. You shouldn't have a lot of hands-on interaction. But generally, these are deployed in bunches, fleets, up to thousands of sites, thousands of points of data collection and data analysis. So machines like the edge compute appliances can do small branch office, larger branch office, or the edge of data collection for streaming video or IoT sensors in an oil drilling platform.
Right. So that is mainly on the networking side, and then at the customer premise or some of the specific use cases, there are a combination of use cases for video analytics and so forth. So where is Matrix OS, or what is Matrix OS really providing on the platform?
So with zero-touch provisioning, we can actually launch to these remote sites and manage the fleet of machines that are doing the collection, but also analyze the data. So people don't want data. There's too much data. There's millions and millions and billions of data points. What you care about is actually the exception. So in AI and ML, the machine trains to learn what normal is and can start to flag what is abnormal. So when you're looking at streaming video, 4K streaming video, 20 megabits of data coming in, if there's nothing in the frame of the camera, why do you care? So it's a data point. So for 20 straight hours, there was nothing there. But once there's motion or a body or a face or a car or something that you asked it to look for, then that's an event, and maybe you want to save that data. So it's not really about data management and data transport from a networking perspective, which is where we all started. It's more about information management and alerting something that you care about through physical security, video analytics, and machine vision.
Okay, and that will represent a couple of use cases, and we picked one of them as an example, which could be a use case applicable for that. Can you highlight a few points on this, Bill?
Sure. So there was a forest fire, I believe, last year out in California that was actually started it was a brush fire that was started by a power incident. And I mean, if you think about the power towers that are carrying those the high voltage transmission lines across the country, there's millions and millions of them. So how do you detect when the brush is dry? Maybe it turned brown. Well, interesting, you can take a camera and look at the color of vegetation to find out if it's dry. You can measure the height of the vegetation from a camera. You can use the power lines to, and not at high bandwidth, actually transfer that data. So this is where we talk about situational awareness, what's happening at a site, and that could be the harmonics coming off of an oil drilling platform will tell you that there's a bearing that's going to go bad that'll cost millions of dollars. So all of these sensors, and just the energy transmission is just one example, but all of these sensors can tell you when something's different, and it's not necessarily wrong, it's different. But you can start to learn when different means danger, or when different means it's going to cost the corporation money. So anything that can give you advance notice of a failure or an incident or an unusual event, and that could be too many customers in a store, I need more cashiers at the checkout. This could be the effectiveness of marketing campaigns in a retail setting. How many people stop and look at a retail display? So all of these things, you could pay someone to stand there and watch, or just tell me if it's different. Tell me if you see something unusual. And the big cloud players have been doing this for ages. If you think about Amazon, they've been using analytics and AI and ML to look at unusual events and say, how is this going to affect my business? So applying this into more real life situations of forest fires, of safety, of public safety, of energy production can make things a lot more efficient. Then combining that network with the data and turning it into information that is actionable means that and there's nothing wrong with cloud, but don't send all of your data to the cloud to analyze. Analyze the data right where it was generated, and you can make a quicker response and a more intelligent response.
Right. Yeah, and I think the prediction part is not only applicable to that use case. I mean, prediction is also maintenance and so forth. I think that's a key element for machine learning and AI, right? To have
Absolutely.
predictability in the network or at the edge in order to identify corrective actions prior to the event actually happening.
Exactly. And that's when we say that situational awareness becomes operational awareness. That the data became information, and now you have an actionable operational change that you can make. Dispatch a person, send out a trouble ticket, order new parts.
Right, correct. Yeah, very good. So the underlying framework for that is, of course, that's why we're here. We want to highlight some of the elements you need in order to create such a solution, and therefore, so we have built appliances which meeting some of the harsh environment platforms in combination with the GPU workload. And in two different areas. One of them is, of course, where all the sensors are being connected, where data points are being collected from the sensors and then analyzed with the AI engine, with Matrix OS. And then down the path, the decision has to be made on what will be further processing needed. And the bulk of some of the data points or collected data points may not be taking place right at the edge side where the sensors are connected. Some of the data points may be for further processing, and therefore requires a different type of workload. And you can see on the bottom right, that's basically a combination of using the analytics tool, using GPU workloads in the platform to do further decisions on the data flow towards either the cloud or to pass back to the edge compute sites. And then, of course, that if you have a mass level of sensoring data, how do you want to monitor that? And that, of course, also needs to be either done through a cloud infrastructure or perhaps creating initial indications of either a threshold for an alarm or for additional corrective actions within the network, right?
Absolutely.
Yeah. Okay, so as far as the platform approach, we have created a framework for that, and working with Tensor Networks in providing a framework in order to do this type of deployment. Beyond this combination, of course, there are some of the elements that needs to be considered, specifically for security levels, access, zero-touch provisioning, but also some of the elements for security in terms of protecting the data we're collecting. So if you have sensoring data, what you collect from an IoT sensor or or a video stream from a camera, requires specific security levels within the platform. And we have been investing into network security over the past years, and we are applied with knowledge in building a framework for a platform supporting the compute resources for GPU acceleration, and that's the key elements to look after the requirements within the network approach. So, Bill, since we're having a wrap up here, how can attendees find out more about Tensor Networks?
Tensor Networks is www.tensornetworks.net. And there's information there that will find you a copy of Matrix OS if you'd like to do a trial.
Yeah, thank you. And if there are additional questions, there is a chat room. We will be happy to answer additional questions from this presentation. And thank you very much for attending. And thank you, Bill, for supporting this.
Great, thank you.